Hi, welcome to the demonstration of integration and validation of iWave's ZU47TR based RFSoC PCI card with MATLAB and Simulink. Before we get into Simulink, let us quickly review the hardware setup with us. For the RF part, we will be connecting the DAC output to ADC input in a loopback configuration. We connect the Type-C debug cable into the Type-C port. We connect the Ethernet cable to the ETH1 port. Then we connect the 12V 5A power supply to the power connector. This is the demo setup. Here we are using the ZU47TR SOM, which is mounted on the PCI carrier card. For the RF section, we have DACs and ADC connected in a loopback configurations. We also have two Ethernet ports, ETH0 and ETH1. For this demonstration, we are going to be using ETH1 port. We also have Type-C debug port and the power connector. The Type-C debug cable should be connected to the COM port of the system, and the Ethernet cable will be connected from the ETH1 port of the board to the Ethernet port of the system. We start by opening MATLAB and add iWave's custom board support files. Next, we open the transmit and receive tone example model. This model is configured to generate a tone using DAC and capture it through the ADC. As you can see, the custom board now appears as a selectable hardware target, confirming that the custom board integration was successful. Once the hardware board is selected, we move on to the build process. To do that, we go to Configure, Build and Deploy, which opens the SoC Builder. Here, we'll proceed by clicking Load Existing Binaries. We then select the project folder. At this point, we need to power on the board. Once the board has finished booting, we run the ifconfig command to check the network configuration. Here, we look specifically for the IP address assigned to the ETH1 interface. After getting the ETH1 IP address, we enter it into MATLAB and test the connectivity of the board. After a successful connection, we click on Next and proceed to load the design onto the board. Once the design is loaded, it opens the software module. Here, we add the spectrum analyzer by copying it from the top model and connecting it into this way. Now, we run the model in external mode so we can monitor real-time data directly from the hardware. On the spectrum analyzer, you can see the received tone, which confirms that both DAC and ADC paths are working correctly on iWave's ZU47TR based RFSoC PCI card. In this example, a 0.5 MHz signal is generated using the DAC and then captured through ADC. The same signal is observed here. So, overall, this demonstrates that our iWave ZU47TR based RFSoC board is fully integrated and working seamlessly with MATLAB and Simulink workflow. Thank you for watching this demo. For more information, please visit our website.